This pretzel-shaped collection of galaxies is our universe. And it's about to collide with another universe. It might be fascinating to watch, but we should probably be worried about what's going to happen when they crash. How would it change the physics of our universe? Is there any chance that we would survive? What would the collision look like from Earth? And has it ever happened before? This is What If? And here's what would happen if our universe collided with another one. The only potential evidence of a universal collision that we've ever discovered is in the form of a cold spot in our universe. In 2013, the European Space Agency's Planck satellite confirmed that this area is 1.8 billion light-years across. It's much colder than the rest of space, and it seems to be missing 10,000 galaxies. At first, scientists were baffled by its existence, but now some have theorized that this spot might be a kind of scar or bruise left from colliding with another universe. But how can we know for sure? And if this is the case, how long before it happens again? Before we go any further, let me take a second to address something that might have some of you scratching your heads. Usually, when we refer to the universe, we're talking about all space and time, including planets, stars, galaxies, and all other forms of matter and energy. So, if the universe basically means everything in existence, then logically there can only be one of them, right? Not necessarily. Some scientists believe in the concept of the multiverse. This theory states that our universe wasn't the only one that popped into existence during the Big Bang, that there's an infinite number of other universes out there too, and we just haven't found a way to see or measure them yet. If this theory is right, then it's possible that all these other universes could have grown at the same rate, at the same time, after the Big Bang. If that's the case, then they might have banged into each other as they expanded. And that brings us back to the cold spot. The cold spot is a region of our universe that's 0.00015 degrees colder than everywhere else. That might not seem like a big deal, but when the rest of the universe's temperature is so consistent, scientists have started to think it's something more than an anomaly. They think that the cold spot might be a scar left over from a collision between universes. And the crash might have moved a bit of energy out of that spot in our universe, causing the colder temperature. But what would a collision of that magnitude look like? Well, we can't say for sure, but there are some pretty cool ideas out there. According to one physicist at the University of California, if another universe came crashing into ours, it would look like a giant mirror in the sky rushing towards us, because its wall would reflect light. If this other universe collided with our own, we could inherit a whole new set of governing laws of physics. Gravity could weaken or disappear, resulting in a slew of planets escaping the gravity of their stars, sending them flying off into space at ridiculous speeds. Without gravity, stars would cease to exist, and we'd be left in perpetual darkness. This would make life on Earth, and throughout most of the universe, nearly impossible. With no shining stars, we'd lose any means of nourishment or breathable air, as plants would no longer be capable of transforming starlight into energy through photosynthesis. But as bad as that all sounds, it's not something we really have to worry about, since the chances of our universe colliding with another one are slim to none. For one thing, we're not even sure that there are other universes out there to collide with. And even if there are, any collisions would have happened at that point when they were expanding, 380,000 years after the Big Bang, which would mean there's little to no chance of it happening again. If you're going to worry about colliding with anything, maybe you should pick something a little more realistic, like an asteroid. But that's a story for another What If. Some 13.8 billion years ago, a very hot, small and dense singularity expanded into what we now call the universe. It hasn't stopped growing since, but what if it did? What if all the galaxies, stars, planets, everything stopped moving away from everything else? Would the universe as it is just freeze? Or would it collapse into a single point, just like it was before the Big Bang? And would that be the end of everything? This is What If, and here's what would happen if the universe stopped expanding. Before the 1920s, when Edwin Hubble observed that the galaxies moved away from each other, we thought the universe was static. Years later, the Hubble Space Telescope showed us that not only is the universe expanding, but it's growing at an ever-increasing rate. This came as a total surprise for astrophysicists. They expected that the expansion was actually slowing down due to the force of gravity. To explain the discovery, they theorized that there's a force speeding up the expansion of the universe. They called it dark energy. What if this hypothesized energy suddenly stopped pulling the universe apart? Let's assume the strength of dark energy diminished over time, but was still enough to counteract the force of gravity. What would that look like? If that were the case, the universe would become just like Albert Einstein imagined it 100 years ago, before Hubble's discovery changed the game and Einstein's viewpoint. It would be static. The universe would neither be expanding nor contracting. Eventually, stars would exhaust all the gas needed for their formation. Fewer new stars would be born, and the existing ones would burn out. The universe would grow darker, packed with black holes. By that time, the Earth would be long gone, absorbed by a red giant star that used to be our Sun. At some point, it would reach its eventual temperature minimum, absolute zero, or 0K. On the Celsius side, that's minus 273 degrees. At that temperature, atoms themselves would stop moving. The universe would become absolutely lifeless. But let's go back and assume that dark energy became so weak that it couldn't counteract the force of gravity anymore. Once the gravity took over, it would pull everything back. The universe would start contracting. Galaxies would draw closer together until they merge into one mega-galaxy. With the stars melding into each other, space would become hotter than the sun, and again packed with black holes, the result of exploding stars. These black holes would suck up everything around them: planets, stars, entire galaxies, even one another. Eventually, they'd form one monstrous black hole that would pull the entire universe into a single point, hot, small, and extremely dense. The universe would end in a big crunch, reverting back into what it looked like at the start. And who knows, the newly formed singularity might explode into another Big Bang, creating a brand new universe with new stars, new planets, and new life forms. We don't know exactly how our universe will end. We don't even understand what the dark energy pulling it apart is. That's why there's not just one theory explaining the ultimate fate of the universe. There are several good ones. Any one of them might be correct, but they could be wrong altogether.
Hey everyone, welcome to another live stream of What If? This week's theme is how the universe ends. You know, most of us are already aware of the various ways the world will come to an end. There's pollution, melting of the polar ice caps, hole in the ozone layer, nuclear annihilation, AI, zombies. But few of us can think big picture enough to envision the end of the entire universe. Lucky for you, I'm one of those people. Later on, we'll be talking about black holes, the big bounce, the big rip. But first, here's a story about my friend Saul. The sun. It's been with us for as long as we can remember. Maybe even before we were here. But she's not going to be here forever.
This is What If, and here's what would happen if the sun exploded tomorrow. That star at the center of our solar system, that super hot ball of plasma that gives us heat and energy, and amazing complexions. Well, it's a ticking time bomb. The Sun is 4.5 billion years old, but it's only expected to last about another 5 billion years. After that, the Sun will expand, becoming a red giant. Then, it will shrink to become a white dwarf, a dying star, cooling for the next several billion years. Of course, we'll all be long gone before any of that happens, but still, can you imagine what it would be like to watch the Sun blow up before your very eyes? With a name like supernova, you'd think that a solar explosion would be the most magnificent fireworks show the world has ever seen. But in reality, you likely wouldn't see anything. The Sun is 150 million kilometers away from Earth, and it takes 8 minutes for light from the Sun to reach us. And while that may seem super far away, in supernova terms, we don't stand a chance. For Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that if the Sun were to explode tomorrow, the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the Sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the Sun's current surface temperature, and permanent darkness. And without the Sun's mass keeping us in orbit, Earth would likely start floating off into space, while its remaining inhabitants desperately struggle to stay alive. There is a chance that our planet could lock into orbit around another star that might provide the same light and heat as our Sun, but by the time that happened, we'd all be long gone. If we knew in advance the day that the Sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. And we could. Just a few meters below the ground you walk on, the Earth is maintaining a temperature of about 17 degrees. So if we had enough time to prepare, civilization could continue to live by moving underground into a huge network of fortified bunkers. Within a week after the explosion, the surface temperature on Earth would drop to minus 18 degrees. Within a year, temperatures would plummet to about minus 73 degrees. At this point, the oceans would begin to freeze from the top down. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. Hopefully, by that point, we'd have found ourselves a new home. The good news is that if the Sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the Sun does die, it will be a long, slow, arduous process taking place over billions of years. The Sun will get hotter and brighter, and it will start to expand. During this process, it will lose its outer layers to the cosmos, leading to the creation of other stars and planets, in the same way that the violent burst of the Big Bang created Earth. Who knows? Maybe new life could form. Can you imagine another Earth? A new humanoid species? It's hard to predict how our galaxy might look billions of years from now, and it's especially hard to imagine our solar system without the great golden anchor that keeps us all together. But one day, in the very, very distant future, the Sun will expand, and then it will shrink, maybe leaving room for a new star to take its place. 13.8 billion years ago, the entire universe emerged from one single point in space. This theory is known as the Big Bang, and it's the most widely accepted story of the creation of our universe. Scientists came up with this universal origin story when they observed that every single galaxy in space is moving away from us, even today. That means that at one point in time, everything could have been condensed into an infinitely dense spot known as a singularity. This singularity was really hot, too. Other evidence of the Big Bang is something known as cosmic microwave background. It's radioactive remnants from the early days of our universe. Remnants that you can only see with the help of a telescope. But what if we have this all wrong? What if the universe didn't start like this? What else were we wrong about? This is What If, and here's what would happen if everything you knew about the universe is wrong. I'm sure you're not looking forward to the end of the universe, but glancing at its future demise could flip your understanding of the universe and its origins. Okay, so you know that our universe is continually expanding outward, so you might assume that it would likely continue expanding forever. Well, this could be true, and this is why the most widely accepted theory involves the universe doing just that. It's called the Big Freeze. And what's really cool about this is a mysterious and invisible force that makes the universe expand. It's called dark energy, and it makes up 69% of the universe's mass. Another 26% of it is made of dark matter, and only 5% of the universe is plain old ordinary matter. If all this material originated from one point and just kept expanding, eventually all this heat and energy would be very, very spread out. At a certain point, everything would be so far away from each other that the entire universe would reach a ridiculously frigid temperature. Absolute zero. Absolute zero is the lowest temperature possible. It translates into 0 Kelvin, or if you prefer a more familiar temperature scale, minus 273 degrees Celsius. By the time the universe reaches this super low temperature, you wouldn't be able to see any distant galaxies from your vantage point in the Milky Way. Don't worry though, that would be at least a couple of trillion years from now. Now, that's just one theory. It's also possible that the death of the universe will be the exact opposite of this. Instead of expanding forever, the universe could shrink back together. Time for the big crunch. All of the matter in the universe, taken as a whole, has an unimaginable amount of gravity. It might be enough gravitational force to battle the mysterious dark energy and win. If this big crunch were to happen, the universe would start to contract in on itself. Galaxy clusters far away would merge. Eventually, stars and planets in our own galactic neighborhood would clump together too. And this increasing density would heat up the whole universe. All that cosmic microwave background radiation from the Big Bang would get so heated that it would be hotter than stars. We're talking 5,000 degrees Celsius hot. The universe would become a scorching, chaotic mess. As temperatures continued to rise and more mass got crushed into a teeny tiny region, atoms would start to break apart. The universe would be turning into the densest black hole possible. While that would certainly be the end of the universe as we know it, it might just be the beginning of a new one. And that would be proof that our universe is much, much older than we thought. The universe may have formed itself over and over again. In this violent cycle of contraction and expansion, you wouldn't have the slightest chance of surviving to witness this epic event firsthand. No one would. So, for now, all of this is just an end of times theory. And it has a big name: the Big Bounce. It suggests that the universe expands and contracts all the time, just like a lung that breathes in and out, only in slow motion. And not just once or twice. According to this theory, there may have been billions, trillions, or even an infinite number of universes, both before and after ours. Each time the universe reforms, it could create completely different laws of physics. This would create all kinds of strange possibilities. There could be universes with no life, no stars, and not even an atom in sight. Now, this is all pretty wild, and it gets wilder from here. Some scientists debate that everything we know about our universe is wrong. What we know about the cosmos is based on what we can see and study in our galactic neighborhood. Then, we assume that it works like that everywhere else in the universe. The idea is old, and it's called the cosmological principle. But we may have been wrong all along. It could be that the way our Milky Way galaxy moves through the universe is distorting our data. I mean, we've never had any hard evidence to confirm our theories, so there's no way of seeing the bigger picture from where we stand. This is where you could be starting to doubt whether any of this is real to begin with. Surely our universe, the one we can see, must exist, right? Well, not so fast. You have quantum mechanics to thank for what I'm going to tell you next. Scientists who study quantum mechanics theorize about the nature of the universe on an atomic level. And according to some scholars in this field, the universe must be one of two things: real or local. Bear with me here. I know this can be mind-numbing. If the universe is real, that would mean that it has specific properties like color and mass that exist even when you're not looking at them. For example, take a red ball. If it's real, the ball is red even when there's no one around to look at it. On the other hand, the universe could be local. This means that the universe can only exist because we are there to observe it through our telescopes. So if you think about the red ball again, without anyone around to observe it, it could have any color or no color at all. Only when you look at it and see that it's red, does it actually become red. That's quantum physics 101. But there's a catch. The universe could be either real or local. It can't be both. And remember that the universe is ridiculously big. It could be infinite. Our telescopes just aren't powerful enough to observe all of it. So that means we can't know for sure if the universe is even real. Whoa, you didn't see that coming, did you? Well, that should be enough of a head-scratcher to keep you pondering about how everything really came to be, where it all could eventually go, and what's the meaning of it all anyway?
Quantum mechanics makes my eyes water and my stomach hurt. Like, it makes me feel as if I'm on my way to my high school art class, only instead I get there and it's advanced abstract algebra. And of course I haven't memorized the Lagrange inversion theorem, so fat chance I'm going to be able to define an explicit form of inverse coefficients given in terms of Bell polynomials. You have that dream too? Our next story is about the Big Rip. Now, that's another way the universe will end, but up here in Canada, we use that term a bit differently. Like, it was hard for me to make this video because I kept wanting to make a story about heading out for a rip to my friend's house. You know, hopping on the skidoo, putting on my toque, and taking a big rip through the back 40. Buddy's got a 2-4 waiting with some ketchup chips and some poutine, and we're gonna have a big rip of our own. Don't worry, this next one's in English.
So, we all know about the Big Bang, right? The cosmic explosion that created our universe? Well, as with everything, there is a beginning and an end. This is the Big Rip, the ultimate fate of our universe. It will be a cosmic event that will tear apart galaxies one by one. Stars, planets, you, everything will be eviscerated. Luckily, it's not going to happen for another 20 to 30 billion years. But what if we weren't so lucky? What if the Big Rip happened tomorrow? What would happen to our planet? And would this really be the end of everything we know? This is What If. And here's what would happen if the Big Rip happened tomorrow. In the future, the Big Rip will literally tear apart the universe. A process that will take about 1 billion years from start to finish. But the mad scientists here at What If have sped up the clock.
So that's, coming along.
The Big Rip is now scheduled for tomorrow. Try to get some sleep now, you've got a big day ahead of you. So, how will this go down exactly? Well, something called dark energy is driving the expansion of the universe. So, as the universe expands, so does the dark energy. During this expansion, dark energy transforms into something called phantom energy. And no, it's not just going through a goth phase. If this transformation happens and the phantom energy increases faster than the expansion of the universe, the Big Rip is set to make its debut. Think of it like a water balloon, and the water is filling the balloon up too fast. Eventually, the balloon will pop. But in this case, it's not a balloon, it's the entire universe. Meanwhile, back on Earth, you're going to have a very, very interesting day. Imagine that you're looking up at the beautiful night sky and you see a shooting star. Wait, that's not a shooting star, that's the Andromeda Galaxy. And it's moving away from us. That's weird. So, since you're confused about what's happening, you whip out your telescope and try to get a closer look. You try to look for other galaxies in the local group of galaxies, but they're gone. Suddenly, all the stars start moving away from you. It looks like you're traveling at light speed. That's the Milky Way breaking apart. You see Saturn shooting through the night sky, and oh my, there goes Jupiter, and oh gosh, you got Mars too. Then, all you see is blackness. The sky is empty of any stars. There's just complete darkness. Okay, it can't get any worse, can it? Well, now the ground is shaking and you see massive tidal waves, earthquakes, and volcanic eruptions. This is because the moon is breaking away from Earth's gravitational pull. But before you even have a chance to react, the Earth will be snatched away from the sun and it's going to get really, really cold. And for the grand finale, our planet will be torn apart and explode. Luckily, you'll be dead by the time this happens. Yeah, you heard me. I said luckily. If you manage to survive long enough during the explosion, you'd be able to witness your own disintegration. All of your molecules would be getting pulled apart. As you unraveled, all the atoms that make up your body would be swirling around, disintegrating into electrons and protons and neutrons. And then, poof, they'd rip apart as well, leaving nothing behind. Nothing is sacred to the Big Rip. And as the universe keeps expanding, it'll get ripped apart too. The universe is gone. Just gone. Or at least, it's gone as we know it. We have no idea what would occur after the Big Rip. That's totally unknown. So, sorry for the spoilers, but that's how we close the book on our universe. Thankfully, we'll all be long dead before the Big Rip happens. Hey, who turned out the stars? Hello? Seriously, where did they go? Is this the end of the universe? Are we all about to get wiped out? This is What If, and here's what would happen if all the stars in the universe exploded at the same time. For every galaxy that's visible from Earth, there are 9 smaller ones that we can't see, even with all the technology we've developed. That's 90% of all space stuff in the observable universe that we're missing out on. We can't even see all the stars in the Milky Way. Our home galaxy is just too cluttered with gas, dust, smaller stars, and, well, one supermassive black hole. All that makes it impossible to tell how many stars there really are out there. But whatever that number is, it sure has a lot of zeros in it. Watching them explode all at once might mean that the Earth is about to become nothing more than dust in space. But there's also a scenario in which we could make it out alive. All stars eventually exhaust their nuclear fuel and die. Some of them depart modestly, first swelling to the stage of a red giant and then slowly cooling down over billions of years. More massive stars explode into a blinding burst of light known as a supernova. As stars go supernova, they spit out a superheated shockwave in all directions, along with a lot of radiation. Supernovas exploding 30 light years away from Earth could send us so much radiation that it would start ripping apart our ozone layer. Once the ozone layer was damaged enough to allow just 10% more UV rays to hit the planet's surface, nearly all marine life would be wiped out. With 2/3 of the ozone layer gone, people living in mid-latitude cities, from London to Melbourne, would start getting severe sunburns. Not even SPF 1000 would save your skin from that much radiation. Some stars would take it a step further. They'd collapse to form black holes. From Earth, this would appear as a lot of bright flashes in the sky. Because of the huge distances involved, the explosions would happen in slow motion. You could see one star exploding for over 10 years as the light from it continued to travel towards Earth. You wouldn't hear any explosions. Sound waves need molecules to travel through. Since space is a vacuum, there'd be no volume. Only a really cool light show. Would the Earth survive these cosmic fireworks? Technically, it's possible. Our planet's surface would be wiped out and all the oceans would boil away. Any survivors would be forced underground, watching out for further damage from exploding stars. But at least life on Earth could have a chance. Wait, am I forgetting something? Right. We'd be sharing our neighborhood with one exploding star. If the sun were to go supernova, all life on Earth would definitely come to an end. The surface of our planet would become 15 times hotter than the surface of the sun right now. That alone would vaporize Earth within a few days. Lucky for us, the sun isn't massive enough to go supernova. But if it exploded, it would send matter in all directions, raining down on Earth 22 hours after the explosion. I'm not gonna lie to you, it would be all bad in the end. But then, exploding stars might form new stars and new planets orbiting them. It would be the beginning of a new universe.
Speaking of star explosions, well, how do you like my hoodie? It's a nebula, the gas and dust thrown out by the explosion of a dying star, and you can get one of your own. Of course, we have a merch store. You didn't know? Check out the What If store at shop.underknown.com. You can get this sweatshirt, this coffee mug, a copy of our book, The What If 100, hats, hoodies, stickers, we got it all. Okay, this next video is about the Big Bounce. I love this theory because I believe this is what's happening with our universe. A period of billions of years of expansion till we can't take it anymore, followed by billions of years of contraction of the universe and continuing in a cyclical process for infinity.
This is the universe. And this little dot here is the Earth. And this is a big bounce coming up. And it's about to squash our planet. Thanks. How long would we have until the Earth got crushed into nothingness? What would we observe from down here? And what would happen next? This is What If, and here's what would happen if the universe was bouncing. It's generally accepted that the universe emerged from one single point of infinite density and then rapidly expanded in what we call the Big Bang. But when it happened, nobody was around to see it for themselves. So here comes a new theory. What if it all didn't start with the Big Bang 13.8 billion years ago? What if, instead, the universe had no beginning and no end, but was expanding and contracting back over and over again? The cyclic universe involves a series of big bounces, where the universe acts like an enormous cosmic lung, inhaling and exhaling a giant breath with every bounce. Basically, you've got nothing to worry about, because the cyclic universe expands for several billion years and then contracts for billions of years. On a scale of a human lifespan, this timeline is just not developing fast enough to affect you in any way. But we here at What If like to add some spice to our stories. In this case, we'll speed things up and have the universe go through its bouncing cycle almost every day. And the next bouncing event is scheduled for tomorrow. You'd start the day with some worrisome news from astrophysicists. The stars and galaxies that normally move slowly away from each other would now be moving toward one another, and fast. Every planet, star, and every galaxy on the edge of the universe would be rushing towards its center, breaking the cosmic lightspeed limit. Black holes would be colliding with other black holes. They'd be sending huge amounts of cosmic radiation in all directions and growing into even bigger black holes. No planet in the universe would have a stable orbit anymore. They'd go flying across the galaxy to meet up at the cosmic downtown. At this point, things would get quite messy on our planet, and you wouldn't be able to do a thing to stop it. So just sit back and watch the world end. As the universe continued to collapse in on itself, its temperature would rapidly become hotter. The superheated temperatures would evaporate our oceans, our planet, and even our atoms. Everything that ever existed would be wiped out. Finally, when the universe contracted to its densest point, it would become a super hot, dense mix of matter. It would slow down for a moment and then suddenly start expanding again. A new bouncing cycle would begin. A totally new universe would emerge. New universe, old rules. From hot cosmic dust, gravity would form new planets, new stars, and new galaxies. And then new life forms would emerge on these new worlds. This new universe would expand until it reaches its limit, and then it would go back to becoming a dense, hot ball of matter. The cycle would repeat, and again, and again, but we would be too long gone to know about it.
They're massive and extremely dense. They rip apart anything and everything that gets close to them. We can't see black holes, but we know they have the destructive power to wipe everything out of existence. This is What If, and here's what would happen if a black hole deleted the universe. Before we get to the part where a black hole erases the universe, let's make something clear. The universe is a giant supercomputer processing information. Without information, there can be no universe. But what is information? In physics, information is the property of a specific state of a particle. I know, it sounds confusing. Here's a simpler way of looking at it. This is a carbon atom. A bunch of these can be arranged to make a hard diamond. But if you change the arrangement of atoms, you can get soft graphite. The basic building blocks are the same, it's information that makes them different. In quantum mechanics, information is like energy. It can't disappear into nothingness. So how, in the universe, can one black hole do the impossible? That's the black hole information paradox. Black holes act like monstrous cosmic trash compactors. They squeeze stars, planets, and unfortunate astronauts who cross the event horizon into a microscopic point. So, what happens to the information about every particle that a black hole consumes? Since information can never be destroyed, it has to be stored somewhere inside that black hole, right? Our original understanding of black holes assumed that everything that disappeared in the black hole stayed in the black hole. The moment an object passed the event horizon, it got crushed into the density of the black hole. The information about it could never be retrieved again. That's what we thought before Stephen Hawking introduced Hawking radiation. Hawking realized that black holes aren't static. Rather, they release their mass and energy back into the universe, particle by particle, until there's nothing left. So, does that mean the information within a black hole can somehow escape with the black hole's outgoing radiation? Not quite. The black hole doesn't preserve the information it consumes, it chaotically mixes it together with other bits of information, making it impossible to recover. The information is lost forever. If the information can be lost, that would mean that black holes can eventually delete the universe. Forever. But there is a possibility that the black hole doesn't delete the information. It may be hiding it in a baby universe, a small, self-contained part of the universe that branched off of ours. The information wouldn't technically be lost, but we wouldn't be able to interact with it. Another possibility is that black holes can encode the information, according to the holographic principle. If you were to get trapped inside a black hole, you'd still experience three-dimensional space. For us, looking at you from the outside, you'd appear stretched on the flat surface, just like a hologram. That would mean that the information paradox is resolved, and we don't need to rewrite the laws of physics. But we'd have to rethink our understanding of reality. The universe could be a three-dimensional image projected off a two-dimensional surface. And you may be a hologram on the surface of a black hole. And the best part? The black hole couldn't delete the universe after all.
Wait, are we living in a hologram? I mean, if we are, I'd prefer it was more like the holodeck on Star Trek The Next Generation. Where we could go on the holodeck and basically ask Alexa or Siri to create a cool holographic VR world that we want to experience. I mean, in this day and age, why would we not have the ability to determine our own experiences? Okay, this next video is a look at the various ways our universe might meet its end, but for me it also served as a bit of a reminder that we end too. Everybody dies. We're here for a good time. Not a long time, so have a good time. The sun can't shine every day.
What if all the stars disappeared tomorrow, together with all the planets, solar systems, and galaxies? What would be left of the universe if it suddenly collapsed? What could make it restart its cosmic cycle all over again? And how exactly could the entire universe break apart? This is What If. And here's what would happen if the universe ended tomorrow. Some 50 million years from now, the Martian moon Phobos will slam into Mars and shatter to pieces. In 100 million years, Earth will likely get hit by an asteroid, the size of the one that caused all the dinosaurs to go extinct. In about 1.5 billion years, the sun will become so luminous that it will force the habitable zone to move outwards, leaving what's left of Earth to get crispy. Everything will eventually come to an end, even our almost 14 billion-year-old universe. What would it be like to witness the epic end of the cosmos? Don't get too comfy. The end of the universe would mean the end of everything in it. 2 trillion galaxies that we can observe from Earth, filled with a tremendous amount of everything, from enormous gas giants to weird-shaped asteroids. Everything would be gone, including you and whoever else is out there. But your last moments could be very different, depending on how the universe shut down. Here are 3 ways it might happen. One possibility is it might get really chilly. The universe is expanding. Galaxies are moving away from each other at an ever-increasing rate, despite the attempts of gravity to pull them back together. That's because a theoretical force called dark energy is opposing the force of gravity. If one day this dark energy pulled a little too hard, the pieces of raw material needed for star formation would become too far away from each other. All the existing stars would eventually run out of fuel, and there would be no new ones to replace them. It would get very dark and very cold. Once the temperature reached absolute zero, nothing would be able to move, not a single atom. The universe would become the most boring, static place, and would probably remain an endless void forever. I bet you were hoping for a more spectacular ending to this story. So let's add more action with the Big Rip. If the dark energy became so intense that it was able to nullify the force of gravity altogether, it would rip the universe apart. It would start with the galaxies, tearing them down one by one. Black holes would be the next to disintegrate, followed by stars, planets, asteroids. As the expansion of the universe ramped up, every form of matter would collapse on itself and decay into radiation. That, of course, includes you. The universe would end up full of single particles. Would it ever come together after its death? Let's try our luck with the Big Crunch theory. If the force of gravity fought back hard enough to overthrow the dark energy, the universe would stop expanding. It would shrink back instead. Planets would collide with other planets, the stars would slam into each other, galaxies would merge together. Earth wouldn't be able to dodge all the space matter for too long. The universe would compress into a very dense singularity, just the way it was before the Big Bang began spewing out galaxies. From that singularity, it could make a fresh cosmic start, with new planets, new stars, new life forms. If you got into a spaceship and traveled long enough and fast enough, could you eventually loop back to where you started? Assuming you don't accidentally collide with another planet or star and no black hole swallows you along the way. This is What If, and here's what would happen if the universe is a loop. We don't know much about the universe. We have no idea how big it is, or where it starts or ends. For years, scientists thought the universe was flat, like a piece of paper, and that if you kept traveling in a straight line through space, you'd just sail off into infinity. But a new study of cosmic microwave background, or CMB, might have just ruined everything we thought we knew about the universe and its shape. What's in it for you? Well, if the universe is a loop, it would mean that a kind of time travel might just be possible. Before we move on to the time travel, let's get the theory out of the way. I'll start with Albert Einstein's theory of relativity. Einstein predicted that space could bend in different ways, meaning the universe could be flat, or curved, or closed. The flat universe was the most likely shape of all, and by that I mean that it fit our current understanding of physics. But then, researchers found something strange in the cosmic microwave background. Figuring out the shape of the universe isn't an easy task. We've never sent a single space probe to the outermost reaches of our universe. Well, we don't even have spacecraft that could possibly go that far. And this is where the CMB comes in handy, the cosmic microwave background. It's microwave radiation that's spread throughout the universe, a relic from its very early ages. Because it's so old, CMB serves as the main source of data about the universe and its past. And by measuring it, scientists can get all kinds of cosmological information. Now, this is the Planck mission satellite. It was sent to measure temperatures in the CMB, among other tasks. But the data that this satellite brought back didn't quite add up. It suggested that gravity was bending the CMB more than the researchers expected. And this isn't something that existing physics can explain. maybe we were wrong about the shape of the universe. Maybe it's closed like one huge inflated balloon. There is a way to test this theory, although it's quite hypothetical. So put your helmet on and buckle up. It's gonna be a long ride. Oh, and by the way, for this task, you'd have to not age for billions of years. You'd also need to build a spaceship with warp drive technology. Equipped with all that, you'd begin your journey around the universe. Don't say I didn't warn you. This one-way voyage would take you billions of years. If the universe is much, much larger than what we can observe, you might only get a third of the way. But if the universe is a loop that's less than 15 billion light years in diameter, you might return to your starting point. That would be solid proof that the universe is indeed a loop and that physics as we understand it doesn't apply. And what was I saying about time? Oh right, Albert Einstein suggested that space and time are connected. So if the space of the universe is looped, could time be looped as well? It might be. The universe could be repeating itself over and over again, from the Big Bang to the Big Crunch. That would explain how the galaxies, with their stars and planets, came into being. And if we live in a looped universe with looped time, maybe, just maybe, one of those young galaxies you can see out there is actually an infant version of the Milky Way. That may not be the kind of time travel you expected. The thing is, the shape of the universe wouldn't have any effect on you or the Earth, or even the entire galaxy, but it might just give us a loophole in covering the astronomical distances involved in exploring the universe.
Welcome to the void. Black holes remain the most mysterious and destructive force in our universe. And when one explodes, the devastation permanently changes the structure of the universe. But what if not one, but all the black holes in the universe suddenly exploded? Would you die instantly? Or would gravity suck you in? And how could you use this cosmic event to book yourself a journey in time? This is What If, and here's what would happen if every black hole suddenly exploded. In 2016, astronomers discovered the remnants of an explosion from a supermassive black hole almost 400 light years from Earth. The event ripped through space and created a cosmic crater wide enough for 18 Milky Way galaxies to fit inside. This one blast ripped apart the Ophiuchus galaxy cluster and raged for over 100 million years. But what did it take to ignite its fuse? A black hole, which is the remains of a dead star, contains a large concentration of matter squeezed into a tiny area. And its gravitational field becomes so strong that all matter and even light gets sucked into its vortex. The Milky Way galaxy alone contains over 400 million black holes. Yeah, in the center of our home galaxy, there's a supermassive black hole, over 4 million solar masses wide. And studies have found that most galaxies have these gravitational monsters at their core. These supermassive black holes, like the one in our backyard, can expand to billions of times the size of the sun. So, is our galaxy a ticking time bomb? Now, speaking of black holes, 1% of these giants has a swirling mass of gas and dust called an accretion disk. The orbiting debris from this disk falls inside the black hole and shoots out at nearly the speed of light.
Guided by twisted magnetic fields, the metals and radiation would burn brightly and return to the cosmos. Debris from the accretion disk endlessly feeds this giant singularity. But what would it take for this behemoth to explode? The black hole would have to take in over 300 million solar masses of gas to create an explosion greater than the one that tore apart the Ophiuchus cluster. And the amount of gas it displaced would equal several trillion suns. Across the universe, the blast would rip galaxies apart and destroy planets. And depending on the amount of gas it took in, the explosion could continue for hundreds of millions of years. Unfortunately for planet Earth, we lay right in the path of a jet stream from Sagittarius A, the supermassive black hole in the Milky Way. Super hot particles ejected from the black hole would slam into our planet along with lethal levels of radiation. Once the X-ray and gamma-ray photons reached Earth, they would destroy the ozone layer within months. With this protective layer gone, how long would it take for the radiation to fry the planet? It would take over 1,000 years for those gamma rays to hit our planet if the closest black hole, HR 6819, exploded. So, while we might see several hundred new bright spots in the sky, it would take a millennium before our planet would feel its effects. I mean, if we're still around. This cataclysmic event wouldn't destroy the entire universe, just large parts of it. But the same materials left behind from the blast would create the seeds for new life. Over hundreds of billions of years, these particles could become new stars, galaxies, or even life. On Earth, time near the edge of the black hole would appear to last billions of years. And near the border of the singularity, an object would seem to hover there endlessly. Our universe was born billions of years ago, and since that time, it's given birth to millions of galaxies, our solar system, and who knows what else. Our universe has been evolving for 13.8 billion years. But how exactly did we get here? Well, strap in, because today we're going back in time to explore the history of the universe in 10 minutes.
In the beginning, there was nothing.
Then suddenly, the Big Bang happened and created our universe. Yeah, okay, maybe it's a little more complicated than that. How this cosmic event began is largely a mystery, but once it got started, it never stopped. Within milliseconds, particles like quarks and photons are formed. They're just some of the building blocks that make up the world you know today. A couple of minutes later, more elements were born. Protons and neutrons combined to create elements like helium and deuterium. And for the next 400 million years, the universe will continue to rapidly expand. After hundreds of millions of years of chaos and rapid expansion, things slow down a bit. This will begin the formation of the first structures of our universe. Think of these structures as the ingredients that make up our stars, galaxies, and even planets like Earth. Next, we see the formation of primordial gas clouds made up of helium and hydrogen, two of the elements that were created earlier. These gas clouds have been pulled together over millions of years through the force of gravity. Once they came together over millions of more years, they slowly got denser and denser. But let's speed this up. As our gas clouds are getting closer and denser, they're also getting hotter. Once the center of one of these clouds reaches 10 million degrees Kelvin, it'll suddenly ignite, creating a process known as nuclear fusion.
The hydrogen atoms will combine to form helium, releasing an incredible amount of energy. Suddenly, the first star in our universe is born. But this isn't the only one. Within these cosmic clouds, billions of stars are now being created. And these aren't just shiny balls of light. They're going to play an integral part in shaping our universe. And not all these stars are identical. As they're born, they'll form into different shapes and sizes. Some will be massive blue giants, while others will be smaller red dwarfs. And it's not just their size that's different, stars have different lifespans too. Some live for tens of millions of years, while others live for trillions. And as we've been observing these stars, something fascinating has been happening. These stars don't like to chill in space by themselves. They want to group together. And it just so happens that when these stars, along with other particles like gas, dark matter, and dust, group together due to gravitational forces, they form galaxies. Yeah, galaxies like the Milky Way and Andromeda were formed in this way. But that won't be for a couple more billion years. Over hundreds of millions of years, the universe continued to expand. More galaxies formed, and they began to evolve in fascinating ways. In a common theme we've been seeing throughout our travels, the galaxies started to gravitate toward each other. As these galaxies begin to pull together, they create galaxy clusters. These are the largest gravitational structures we know of. At this time, we're also seeing some of the stars that formed near the beginning of the universe starting to die out. They're exploding into supernovas. But don't be sad that they're dying. These supernovas are a necessary sacrifice to provide the universe with essential elements that will later create planets and life. Speaking of essential elements, I should also mention dark matter. This is a mysterious substance that doesn't emit or absorb any light and plays a pivotal role in the tapestry of the universe. Even though we can't see dark matter, we know that it has a strong pull that has helped shape everything up until now. Dark matter is like a hidden framework that's helped form our galaxy clusters and other elements of the universe. Okay, now is when things get a little more familiar. After several smaller galaxies come together, the Milky Way begins to form. Our sister galaxy, the Andromeda galaxy, is also created during this time. And in other similar galaxies, solar systems are starting to be created. Enormous clouds of gas and dust collapse under their own gravity, bonding together and creating early planets and solar systems. And it only gets more interesting from here. Okay, we've been away for a couple billion years, and during that time, the universe has continued to expand. More solar systems and galaxies are formed, and way more stars have been created. Speaking of stars, arguably the most important star in all of space was born: our Sun. After our Sun is born, extra gas and dust surround it. Over time, these particles clump together, eventually growing larger and larger. This process is called planetesimals, the beginning of the planets we know today in our solar system. Over time, these planetesimals grow larger and larger through countless collisions and gravitational attractions. One of these protoplanets that's emerging is Earth. Its growth is marked by a pivotal event. A Mars-sized body known as Theia crashes into our planetesimal, which creates what we now call Earth and our Moon. Similar collisions of celestial bodies create the other rocky planets we know today: Mercury, Venus, and Mars. Over in the cooler regions of space further away from the Sun, gas giants like Jupiter and Saturn are forming. But checking back in on our rocky planets, they look significantly different than they do in the present day. They're a lot smoother than I remember. Well, just wait a couple more million years for what's known as the Late Heavy Bombardment to occur. This cosmic event saw massive asteroids hit these rocky planets. It played a huge role in how they're shaped today. Okay, after billions and billions of years, we finally start to see life appear in our universe. But don't get too excited. These are simple, single-celled organisms known as prokaryotes. They lack many of the essential features for life today, but are still an important part of our evolution. You currently have trillions of them living on your body. Not long after this, oxygen begins to appear on Earth, and so do multi-celled organisms. Earth's climate is beginning to take shape, and we see the introduction of the ozone layer, which protects life from harmful radiation from space. Okay, another couple billion years have passed, and a lot has happened. The organisms that were microscopic have evolved to become creatures with vertebrae. This is a significant milestone and a precursor to all other vertebrate life on Earth, including you. And even more change happens during this time. Plants are evolving and continents are moving. This is the age of reptiles and Pangea, but it also had its shortcomings. A mass extinction event occurs, wiping out a vast majority of the species that have been so patiently evolving. This sets the stage for dinosaurs and mammals to emerge. And as this era comes to a close, Pangea begins to fragment, laying the groundwork for our modern continents. And now we're here. In the hundreds of millions of years that have passed, humans have arrived and evolved. Modern civilization was born. And now we're looking to move forward again. Who knows what's next? Space travel? Climate change? Future technology? I guess we'll find out when we travel 1 billion years into the future. Okay, everyone, thanks for joining us on this veritably violent voyage through the universe. I hope you enjoyed it and hope you learned a lot. We'll be back soon with another What If?
This pretzel-shaped collection of galaxies is our universe. And it's about to collide with another universe.